In this video, we'll be looking at an open system input-output model. In our example, we have a simple economy with three commodities. In this economy, the production of 1 unit of agriculture requires 1/4 unit of agriculture, 1/3 unit of manufacturing, and 1/4 unit of energy. The production of 1 unit of manufacturing requires 1/3 unit of agriculture, 1/4 unit of manufacturing, and 1/2 unit of energy. The production of 1 unit of energy requires 1/5 unit of agriculture and 1/3 unit of manufacturing. And in this, we want to satisfy a demand of 41 units of agriculture, 81 units of manufacturing, and 70 units of energy. So the first thing we need to do is set up our input-output matrix. Now, since this is an input-output problem, the inputs are the same as the outputs, which means for our matrix, the rows will be agriculture, manufacturing, and energy, and the columns will also be agriculture, manufacturing, and energy. Now, to fill in the values of this matrix, what we need to know is how much it costs to produce 1 unit of each commodity, and those numbers will go in the column under that commodity. So for example, the production of 1 unit of agriculture requires a 1/4 unit of agriculture, a 1/3 unit of manufacturing, and a 1/4 unit of energy. And those numbers go in the first column, so those tell us the costs of producing 1 unit of agriculture. To produce 1 unit of manufacturing, we need a 1/3 unit of agriculture, a 1/4 unit of manufacturing, and a 1/2 unit of energy. To produce 1 unit of energy, we need 1/5 unit of agriculture, 1/3 unit manufacturing, and it doesn't say anything about energy, so we'll assume that's 0. And this is our matrix we'll call A. Now we also need our demand matrix D, and our demand matrix is how much we want to have left over after we've produced a certain amount, and some of that is consumed in the process. So we want to have left over 41 units of agriculture, 81 units of manufacturing, and 70 units of energy. And so to solve this, what we'll use is the formula I minus A inverse times D. And so to do that, we'll need to put all of these matrices in our calculator. I've already got matrix A and matrix D in our calculator. When you type these in, you'll type them in as fractions, and the calculator will convert them to decimals. So that's matrix A and then matrix D, 41, 81, and 70. I like to use matrix A and D as the letters, since those correspond to those in the formula. Alright, I is our identity matrix, and we can get that from our calculator as well. So we'll push the parenthesis button, we'll go second and then matrix, over 1 to math, and then down to identity. Now the identity matrix is square, so we only need to give it 1 dimension. And since A is a 3x3, our identity will be a 3x3 also. So we want to do the identity matrix minus our A matrix. Close that parenthesis. We'll take the inverse, and then we'll multiply that by matrix D. And so we get our answer, which tells us how much must be produced to have left over the demand that we want. So rounding to the nearest whole unit, we would need 339 units of agriculture, 421 units of manufacturing, and 365 units of energy. And if that much is produced, then what we would have left over is 41 units of agriculture, 81 units of manufacturing, and 70 units of energy.